So we'll see about automotive brake systems. We all know that law of conservation of energy. Energy can neither be created nor be destroyed, but it can be transformed from one form of energy to another form of energy. Okay, we have various forms of energy. You have thermal energy, heat and mechanical energy, chemical energy. Okay, so energy can neither be created nor be destroyed, but it can be transformed from one form of energy to another form of energy. See now, in the case of brake, you have called friction braking. So here what happens is the kinetic energy of the vehicle, which means half mv square, the velocity of the vehicle, is converted to the thermal energy. Okay, and then it is dissipated to the atmosphere. That's what it's happening in the case of atmosphere. It's happening in the case of a friction breaker application, where the kinetic energy is converted to thermal energy and then it's distributed to the atmosphere. Now let us take a two application. One is the powertrain application, and one is a brake application. You see which power is more powerful, acceleration power or the braking power, which is more powerful. Let us see. So let us consider a vehicle having the vehicle mass as 10,000 kg. Okay, so this is the mass of the vehicle. Now the vehicle is moving from 0 to 72 kilometers per hour in 20 seconds, which is nothing but acceleration power, where you are accelerating the vehicle from 0 to 72. And in the case of brake, what happens? The 72 kilometer will become 0, right? This is what you call this as a braking power. This is called as accelerating power. And acceleration should happen, say for an example, we are considering the time means in 20 seconds, you are reaching from 0 to 72 kilometer per hour, which is nothing but 20 meter per second. Okay, 20 meter per second. The 72 kilometer per hour is nothing but 20 meter per second. Okay. Now, what happens here? Same 72 meter, 20 meter per second to 0 meter per second, you are achieving in 4 seconds. In the case of brake, in the case of brake, what happens? You are decelerating the power, which means you are reducing the speed, right? Some 72. That's why it's called deceleration power or the braking power. Now you know that the formula for average acceleration is nothing but final velocity minus initial velocity. What is the final velocity? 20 meter per second. Minus what is initial velocity? 0 meter per second. The rate of change of velocity to that of time, you call this as average acceleration. What is rate of change of velocity? Which is nothing but final velocity minus initial velocity divided by what is time t, which is nothing but 20 seconds, right? It's nothing but 20 seconds. So I'm putting is 27 here. So when you do this, what happens? You will get 20 by 20 meter per second by 20 second. It is nothing. 20 gets cancelled. So you get 1 meter per s by s will becomes s square. So it's called 1 meter per second square. Okay. Now similarly, we are going for the brake application. Similarly, we are going for a brake application where you see that average acceleration is nothing but final velocity minus initial velocity, the rate of change of velocity. What is final velocity? It's 0 kilometer per hour or 0 meter per second. Or when you take 72 kilometer per hour is nothing but 20 meter per second. So when you do the calculation, okay, so you can also try the calculation. 72 kilometer per hour is equal to 20 meter per second. So final velocity minus initial velocity is nothing but the rate of change of velocity. The difference between the rate of change of velocity to that of the time taken. So the time taken here is 4 seconds. So it is called, you call this as 20 by 4 will become 5 meter per second, and second into will become second square. So it is called negative, it's minus here, so it's called minus 5 meter per second square. Now we are going for a calculation as of acceleration power and braking power. We know that acceleration power, or the power is nothing but half mv square divided by the delta t, or the time taken. So we know that of m is nothing but what? Mass of the vehicle. What is the mass of the vehicle? It is nothing but 10,000 kg. Okay, and mv square, v is nothing but what? Final velocity minus initial velocity. We know that final velocity is 20. So that's why I'm putting 20 square minus 0 square divided by delta t is nothing but 20 second. So when you do this, what happens? You get the acceleration power is 100 kilowatt. Okay, which is more powerful. Okay, people think that increasing the speed of the vehicle from 0 to 500, 0 to 250 kilometer per hour, 0 to 100 kilometer per hour, 0 to 125, depending upon the specification. That people think that acceleration power is more powerful than the braking power. It is other way around. This just for an example we have taken here. If considering this for the same mass of the vehicle, between when you're considering the acceleration power to the brake power, which is more powerful? Okay, is this the acceleration power is more powerful or the braking power is more powerful? Of course, acceleration power is nothing but you are increasing the speed of the vehicle from 0 to the required maximum limit in so and so time. Similarly, once you reach the maximum speed, what's the time taken for you to come to 0 speed in the particular time taken? Okay. So for the same thing, what you see here when you're calculating the braking power, which is nothing but half m, final velocity is nothing but 0 in this case, and the initial velocity is going to be 20. So when you do the calculation with respect to time, considering 4 second, you get 500 kilowatt. So which is more powerful? 100 kilowatt is more or 500 kilowatt is more? So obviously, 500 kilowatt is more. So that's why the braking power is higher than the acceleration power. Because what happens, you have the lesser time. Okay, so the time taken for you to accelerate is much more higher than the rate of deceleration. Okay, this also depends on what type of brake you're going to use. You also have different types of brake system. This is going to be drum brake or disc brake, or what type of medium you're going to use. Are you going to use the air brake system or hydraulic brake system, or going for anti-lock braking system? So it also depends on those parameters as well, which will also determine what's the minimum time required, because the reaction time is very much important, which needs to be as low as possible so that the braking power becomes much more effective. So let us see what are all the different functions of the brake system. Okay. So these are all the functions. The first one is that it should decelerate the vehicle. That's what we have seen here, right? From 72 kilometer per hour to 0 kilometer per hour, it is getting decelerated. And it should also stop completely, or it should reach some the limited speed whenever it's required, which means it should provide sufficient brake force, right? The function of the brake is that the first important function is that it should provide a sufficient brake force, which means it should decelerate the vehicle and it should stop the vehicle whenever it's necessary. And second is that it should maintain the speed of the vehicle while you're traveling the vehicle when you're traveling it downhill. Okay, because downhill what happens, when you're driving the vehicle, the speed can be slightly higher. Okay, for the less effort of the way of the driver, it will be much more higher. The speed will be higher. So it's very important that the speed of the vehicle should be maintained when you're traveling downhill, for which the brake is very much important. which means it should dissipate the heat energy effectively. So the second function is that it should dissipate the heat energy effectively, and also it will maintain the speed of the vehicle when you're traveling downhill. And the third important function is that it should hold the vehicle stationary during the gradient. When you're upfilling, when you're going for a gradient or a grade surface where you're taking it uphill kind of thing, it should also hold the vehicle stationary. It should not unhold the vehicle. It should hold the vehicle properly, such a way it helps during the gradient condition. So these three functions is very much important. First is that it should provide the efficient, sufficient brake force, where it helps for decelerating the vehicle and stopping it whenever it's necessary. And then it should also dissipate the heat energy effectively by maintaining the speed of the vehicle when you're traveling in the vehicle downhill. And it should also hold a vehicle in a stationary as in the case of gradient condition. And let's see the evaluation of the brake system, how it is getting, how the evaluation has happened. Uh, first initially the wheels were braked by wedging a shoe against the rim. So assuming that this is the wheel rim, okay, and this is the brake shoe, okay, and this is the lever, okay. So this is the mechanism of the initial brake system, um, where the wheels were braked by wedging a shoe against the rim. So this shoe will hold the rim, so that the deceleration of the vehicle is going to happen. When you're pulling the lever, this shoe will be moving towards the rim, and then it hold it, and then the vehicle gets decelerated. This is the initial stage. Next, what happens is that it can brake called a band brake, where so this is a schematic diagram of band brake, where we have the brake lever, and then you have a, assuming that the blue one is the wheel hub or a drum, and the center one is the lining, friction lining material, the brake lining material, brake lining, and the last one, okay, that it is highlighted in green, is nothing but a brake band. Okay, what happens when you apply the brake? Okay, when you push the brake lever, when you apply the force like this, what happens is that the band, which is the brake band, which is in the outer portion, may rub against the drum. It pushes the brake lining material, and this brake line material will in turn push the it will in turn push the drum or wheel hub because of the thermal expansion. Okay, what happens here? The gap between the band and then the friction lining material may reduce, but depending upon the life of the band brake. And what happens? There is one more evaluation has happened, which is nothing but a drum brake. Okay, where see here in the case of band brake, what happens? The external surface, which is nothing but the band, it the gap between the band and then the lining, it expands basically. Okay, sorry, it contracts. It contracts. It's already externally contracting. So as a result of that contracting, what happens? The gap reduces. Okay, and you have next comes the internal expanding brake, where in this case you call this as a drum brake. The outer portion is drum, and the center one is the brake lining, and then you have a brake shoe here in this application, which is pivoted at the ends, and by the spring force, what happens here? Um, this moves towards like this. Okay, internally it expands. Okay, it internally expands, which means the brake shoe expands, and then it touches with the lining, and then the brake lining expands the such a way it, it holds the drum. Okay, so what happens here? It expands, which means the gap it expands between the lining material and the drum, and this is the third revolution. First evolution is that the normal wedging shoe against the rim. Next is going to be the band brake, which is nothing but the external contracting brake, and the third one is going to be the internal expanding brake, which is called as the drum brake, and the last one is going to be the disc brake. So this is how the evaluation has happened from normal brake shoe rubbing against the rim to the top the disc brake. Of course, we have various types of brakes, which you call as a drum brake, disc brake. It is called as a foundation brake. How you are going to group the brake system? Okay, you have various brakes. You first is nothing but it's based on the functions. Okay, so that's why it's called as function grouping of brakes. First one is the service brake, where this is used for the normal brake application. Okay, you have a parking brake as well. During a parking application, you use this, and you have a secondary brake or an emergency brake. It has been used during the partial brake failure. You have that's why you have a dual circuit in all the cars and also truck application, where if in case one primary primary circuit fails, the secondary circuit will be functioning. So in the case of any complete brake failure or a partial brake failure, you have a secondary brake application or a secondary brake system or the emergency brake system, which will help for the deceleration of the vehicle. Okay, let's let's take a small break, maybe some 10 minutes. We'll resume back by 2:05. Okay, uh, just we'll take some 5 minutes break and then we'll come back. Then after that, we'll see the different parameters of the brake system and what are different components of the brake system, and we'll see some brake application. We are not going to see complete brake systems today. So we'll see drum brake, and then we'll see the disc brake, and then we'll see hydraulic brake system, and then we'll also see the air brake system as well. And the ABS we will see in next class. Okay, so these things you will see today. Let's have a short break. And so for just a small recap, what we have seen. So we have seen different wheel alignment parameters, and then basics about the brakes and what sort of function of brakes, and then how the brakes is gets evolved, and then grouping of the brake, what are the different groups that the brake has been divided. And in fact, we will also see the brake parking brake as well in the next class, followed by ABS. Okay. Okay, let's take a 10 minutes break. So we have seen what are the different groups of the brake system. Service brake, which is used for normal braking application, and secondary or the emergency brake, which is being used during the partial brake failure, and the third one is nothing but a parking brake. Now we'll see the different parameters of the brake system. Okay. See, normally what we call the stopping distance. So when you apply the brake, at what distance it stops, that is nothing but the stopping distance. But what there are different parameters involved while calculating the stopping distance. So it is nothing but the summation of the three distances. Okay, first one is that the driver reaction time. Okay, which is nothing but TDR, driver reaction time. Okay. Next comes the response time, brake response time, which is TBR. And third is nothing but the brake time, which is nothing but TB. Now, assuming that the vehicle is running in highway, and suddenly if some objects or some any creatures is coming in between, what happens? The driver will see some objects are coming, some humans are coming, some animals are coming. So he reacts to that, right? The driver takes some time to apply the brake. Okay, that is nothing but the driver reaction time. Why the driver will apply the brake to decelerate the vehicle? And after that, what happens? Once he applies the brake, then there is also a brake response time. Okay, first he takes some time to react. Next he takes the brake response time will be there, where brake will not be applied immediately. Okay, once after that he presses the pedal, brake pedal or brake hand lever. Okay, in the case of two-wheeler you have as a hand brake, and in the case of four-wheeler application you have as a foot pedal brake. Okay, so that also takes some time. It's nothing but the brake response time. And then after you apply the brake, after the driver applies the brake, uh, again the vehicle is not going to decelerate to the high to zero immediately, right? It takes some time. That time is called as braking time. And this stopping distance is nothing but the summation of TDR plus TBR plus TB. Now let us see this in the case of schematics. So assume that this is a time, this is a deceleration, you're decelerating the vehicle. Now the vehicle is running with some speed. Okay. So first, assuming that the vehicle is running with 72, let us take the same example of 72 only. The vehicle is running at 72 km per hour, and suddenly when the vehicle is running in highway 72 km per hour, if there is any objects or any human passing the vehicle, if they come in between, what happens? The driver reacts to it, and to apply the brake, that is nothing but the reaction time, driver reaction time. Then he applies the brake. Okay, he applies the brake, that is nothing but the braking time, sorry, brake response time. And once he applies the brake, what happens? The deceleration is going to happen. It's not acceleration, it's a deceleration. Vehicle decelerates from 72 to, say for example, with respect to the increase in time, 72, 60, 50, 40, 30, 20. Okay, 10. Okay, 10. And it's not necessary that it should be 0 km per hour, because if that person who is crossing, or if the object is getting crossed, or if any animals is coming in between, if it is getting crossed, the deceleration need not be 0. It can be 10 km or 15, and by the time again he can continue with that, or there is some possibility that he have to decelerate completely to 0. Okay, so if it is 0, then again further you will take it there, and again it becomes 0. See, now in this case, we are decelerating it from 72 to, say for example, 20 kbh, or even further to 0, depending upon whether the objects or the person is, uh, is not coming in between. Okay, so now with respect to the increase in the time, the deceleration happens, and then it maintains means it remains same. Okay, it can be 0, or it can be the required speed what is being required. Now what happens? So this is nothing but the braking time. it's nothing but a stopping distance. But again, sorry, there is a change in the statement, my statement. I have told you the time required uh, from 72 kilometer to 20 kilometer or 15 or whatever it's required. But this stopping distance is nothing but the time required for the complete stoppage of the vehicle, which means from 72 kilometer to 0 kilometer per hour. 0 kilometer per hour. What is the time required for for the braking? Means what's the time required for the braking to happen, which means to decelerate the vehicle from 72 to 0 kilometer per hour. It's not 20 or 15. There are some instances where we don't stop the vehicle instantaneously. We reduce the speed and then we continue accelerating it, right? If there is no obstacle or there is no constraint. But here we normally call the stopping distances considering the constraints where we are decelerating the vehicle from the maximum speed or the speed which is there to that of the zero speed. Okay, that you call as a stopping distance. So it's nothing but you are going to stop the vehicle. Okay, and you call this as a braking time. And this three summation is called completely as a stopping distance. Now you have the distance, which is nothing but, so this is the deceleration versus time, and again time versus distance. See what happens when you apply when the object is coming to some distance. Uh, the driver react to it, and then afterwards what happens? He will apply some brakes. Okay, he will apply the brake, which is nothing but up to here he applied the brake, and up to this point you call it as a reaction distance. Okay, where uh, TDR and TBR is nothing but reaction distance. Okay, and then on the moment when he applies the brake, what's the time required for the vehicle to stop? Okay, it's called the stopping distance. Okay, this is the distance which gets stopped, and here comes the braking distance, and this stopping distance is nothing but the reaction distance plus braking distance. Okay, you call this as the stopping distance. And also this the time also, this reaction time or the braking time, it also depends on the tire road interface. See what happens, reaction time may be same, brake response time also may be same, but what happens, the braking time, if the road is wet, because of the rain, what happens, uh, it also depends on tire road interface. Okay, if the vehicle is running in normal road, you will have less stopping distance, and assuming that the vehicle is running in a heavy rain condition where the road is completely wet, and the braking time may be increased, right, because of the road pattern. And in such scenario, what happens, the stopping distance might increase, the braking distance may increase. When there is an increase in the braking distance, the stopping distance is also going to get increased, which means this stopping distance is also based on the tire road interface. Okay, which means the tire and the road surface is very much important. Whether the road is smooth or the road is wet. Okay, so that surface is also to be defined. Whether the road is rough, whether the vehicle is running in city condition, city plus highway, or a rough road or hilly area, it all matters. And again, the road is curvy. Okay, and the third parameter is this. So the second parameter, first parameter is the stopping distance, which is an important parameter of brake system. Second parameter is the braking stability or the stability of the vehicle during braking. It means here a good brake must ensure a short stopping distance while maintaining the vehicle in a stable condition. That's what I have told. And this also requires a proper distribution of the brake forces at the front end and the rear wheel. That's why braking stability is very much important. The third parameter is reliability, where so here one more thing that I need to highlight here is in the braking stability, what happens? It's not only the stopping distance matters, less stopping distance matters, but you also need to maintain the vehicle in a stable condition. The vehicle should be running in a stable condition. Okay, that this is a very key point here. The stable condition is very much important. And in order to achieve the stability of the vehicle during braking, you need to have the proper distribution of brake forces. The brake should be applied properly in both the front wheels and also rear wheels. Front wheel you have left hand and right front wheel, and then right and left rear wheels. So all the four wheels should be equally distributed with respect to the brake forces, so that you will maintain the stability during the braking. Let's say braking stability is very much important. Okay, it's not that you apply uneven braking and then the stability of the vehicle is getting affected. So that's why not only stopping distance matters, even the stability is also important. And then the third parameter is reliability. In addition to the stability and then braking stopping distance, the reliability is also very much important. Where you have a lot of transmission parts such as mechanical links, hydraulic systems, compressed air systems. So all these are the braking system. For example, hydraulic brake or a hydraulic brake system or air brake system or drum brake or disc brake, mechanical link. Basically, the transmission system is typically the weakest link in the brake system. All you know that this is the weakest link, and hence you need to have a better reliable for these links basically, and hence you need to have a redundancy which is needs to be introduced, that has led to the use of dual circuit brake system. Why we need to have the dual circuit brake system? Okay, you have basically if in case if one circuit fails, the other circuit will help basically. That's why it's called dual circuit brake system. Okay, um, if you have two circuit, one is primary circuit, secondary circuit. If primary circuit fails or the secondary circuit fails, the other circuit will help for the proper application of brake in the case of hydraulic system or air compressor system. In hydraulics you used a lot of hydraulic application. What happens if one of the circuit gets failed? You need to have the backup, right? You need to have a redundant system such a way it will not affect the reliability of your brake system. So this is also one of the parameters that you need to consider along with the stopping distance, braking stability. Reliability is also very much important. Let's see the different components of the brake system. And what are different components? First is what is source for the brake system? Okay, so human effort is the brake. It's a source, right? Either in the case of two-wheeler, the people apply the brake with the help of a hand lever, or in the case of four-wheeler, they apply the brake using a pedal with the help of a leg. So the human effort is the source of energy that needs to be taken into consideration. And then you also have a brake assisted systems, which is nothing but a vacuum booster. You also have a power brake where the driver input is used to modulate a source of energy, example air brake. So these are some of the source of energy. And then what was the mechanism that you are applying the brake? Is it going to be the foot pedal or is it going to be the hand levers? And the third important thing that you need to consider is it going to be the mechanical brake or a hydraulic brake or air brake, or is it going to be the combination? When you're going for the mechanical brake, you use levers, right? You use rods, you use cables to transmit energy. In the case of hydraulic brake, you use some incompressible brake fluid, and in the case of air brake, what you use is you use some compressed air, and it can also be air over hydraulic, which is nothing but a combination type. So these are some of the energy transmitting medium in the case of brake application. Now you have the split brake system where in the case of single, you have two circuit system, one is single circuit, another one is a dual circuit. So in the case of single circuit, what happens? We use only one circuit for transmitting energy required for braking. If in case if that circuit, if this circuit fails, there is no braking available. Okay. So that's why we need to have the proper safety aspects. So that's why we are going for a redundancy reliable system, which is nothing but a dual circuit system, where it uses two circuits to transmit energy. So and again, at least if one circuit fails, at least we have partial braking in the event of failure. It is very much helpful. And you also know that you have the thermal expansion, right? You have the thermal expansion of the brake drum, which is resulting in the clearance increase. And we also know that there is one more parameters called brake fading parameters, where there is a reduction in the brake friction to lining coefficient with increase in the temperature. So when there is an increase in temperature, what happens? Not only the thermal expansion of the brake drum will increase the clearance, but also there is also going to be a brake fade where there is going to be the reduction in the brake friction lining coefficient with the increase in the temperature. And the next important thing is that you have the foundation brake, which is nothing but a drum brake and disc brake, which is nothing but the brakes which is being used at the wheels. Now, the first thing we will see is the drum brake. You can see this is the brake drum, and you have the friction brake lining in between the drum, and you have the brake shoe. You have the leading brake shoe, and another one is the trailing brake shoe. And you have the wheel cylinder, you have the spring, return spring, and this is the brake shoe, this is the brake lining, friction lining, and this is the uh, brake drum. This is the brake drum. Outside is the brake drum, and you have this is the leading shoe, and this is the trailing shoe. Okay, sorry, you can call this as the leading shoe, and this is the trailing shoe. And you also have the spring, return spring. Okay, and you also have the wheel cylinder. This is you also have the S-cam spring, and you have the wheels as well. And as I told you, the thermal expansion of the brake drum will result in the increased clearance, and the brake fading is also going to happen when there is a reduction in the brake friction lining coefficient. When there is a reduction in this coefficient brake lining, what happens with respect to the increase in temperature? This will affect the parameters. This will result in the thermal expansion of the drum. There will be thermal expansion will happen, which means it will increase the clearance between the drum and then the brake lining or the brake friction lining basically. Now let us do some analysis, neglecting the weight of the brake shoe. I'm not considering the brake shoe weight, and I'm neglecting the spring retention force. Okay. Now what happens? We are going for a simple free body diagram where nu is nothing but the brake lining coefficient. Now I am applying the force, actuation force here. This is the leading brake shoe, and this is the trailing brake shoe. So I'm taking only the leading brake shoe first and then trailing brake shoe first, and I'm adding these two brake shoe to find out the effect. Okay, see now this is the actuation force, and NL is nothing but a lumped force basically. And you know nu is nothing but a friction, and this friction force acting in the perpendicular direction to that of NL. Okay, Now, assuming that overall height is going to be h, and the distance between the bottom to the top of the center is b, and this distance is nothing but a, and when you're taking the moment, you have x and y, rx and ry. Okay, and now the torque. So when I'm taking the moment, you see here FA actuation force is acting towards this direction. So FA into H plus this is acting to down direction. Okay, nu into NL into A. Okay, I'm taking the moment about this, about this. Okay, okay, I'm taking the moment about this point. And now you know NL. Okay, this is NL. NL into B. It will be in the minus direction. Okay, so because this is acting towards right. Okay, so it is in minus direction. So FA into H plus nu into NL into A minus LL into B is equal to 0. And this two you call this as a torque due to the friction force arguments that lead to the that is due to the actuation force. This is termed as the self-energization. And how we can call NL? NL is nothing but the friction force uh, from the leading shoe. So L stands for leading and T is trailing. So this is the force, lumped force. N is the lumped force considering the leading shoe. So now the friction force from the leading shoe is nothing but nu into NL, right? So nu into NL is nothing but friction force from the leading shoe. Now you know that nu into NL is nothing but what? FA into H by B minus nu into A. Now the brake factor BF for a leading shoe is nothing but how I can write it's nu NL by FA. So when you take the friction force to the top of the actuation force, the ratio between the friction force from the leading shoe to the top of the actuation force, you call this as a brake factor of the leading shoe. And this is the formula. Okay, nu H divided by B minus nu into A. Now the reverse is going to happen, assuming that I'm going to take a moment about the pivot point P with respect to the trailing shoe. Okay, so again, this is going to be nu into NT, where NT is nothing but FA into H by B plus nu A. Okay, so here what happens? FA into H, FA is nothing but what? Actuation force into H minus nu into NT is nothing but what? Nu into NT is nothing but the friction force from the trailing shoe. Okay, and from this you can calculate what is NT, and this is nu into NT is this formula. And now the brake factor for the trailing shoe is given as BFT, which is nothing but um, which is nothing but a friction force from the trailing shoe to the ratio between the friction force from the trailing shoe to that of the actuation force. So that is nothing but nu H by B plus nu A. Now what happens? What is the overall brake force, brake factor for a drum? The brake factor for the drum is nothing but the brake factor for the leading plus brake factor for the trailing. So when you add these two, what happens? Nu H by divided by B minus nu A plus nu H by B plus nu A. So this is the overall brake factor for the drum brake. Now similarly you have the disc brake where you have a rotor. This is a rotor. Okay. And you have discs, left disc, right disc, and you have the caliper assembly, and this is the brake pad. And you have a fixed caliper or and this caliper what you have is it can be either a floating caliper or it can be either fixed caliper, but again we always go for a floating caliper because it will adjust the distance. So what happens here is assuming that FA is nothing but actuation force and N is nothing but the load. It can be either in the leading edge or in the trailing edge, but here in this case we don't have the leading or trailing. So but what we take here is we take as a nu into n. So that's why at the steady state load is equal to the actuation force, and the friction force from the brake pad is nothing but nu into n, which is nothing but n nu into fa. And the brake factor for one brake pad, you have two brake pad, right, left and right, so it is nothing but going to be nu. And the brake factor for the complete disc brake, you have two factor, right, 2 1 and 2. So brake factor for the disc brake is going to be 2 nu. Now considering the same value of friction, if you have the same friction for brake drum and also brake disc and also disc brake, disc brake and also drum brake, what happens is for the same value of friction, the brake factor of the drum brake is greater than that of the brake factor of the disc brake. So drum brake is much advantageous if you have the same friction. Okay, for the same friction, the drum brake is having better higher higher brake factor for drum brake than that of the disc brake. And again, which means you need to have the more brake force output for the from the drum brake for the same actuation force. And for obtaining the same brake force, a small actuation force is required in the case of drum. This is the meaning basically. In the case of disc brake, you need to have the more actuation force. In the case of drum brake, it is required less. For the same actuation force, we also get a brake output force, which is coming more in the case of drum brake. So these two are the takeaway for this statement, where the brake factor BF is higher for a drum brake than that of the disc brake for the same friction. Now let us analyze this with the help of a graph. Okay, nu is the friction and this is the brake factor. So first one is you can take this is the I have told you that brake factor of a drum is higher, and then the brake factor of disc will be going to be lesser. Okay, so this is going to be drum brake and this is going to be the disc one. Okay, blue one is the drum and this is the brake factor for the disc. Now what happens, assuming that this is for the same value of nu, assuming that for the same value of nu, the drum brake brake factor is higher than the disc brake drum brake factor. Now what happens, I am going to reduce the nu to minus delta u. So I'm reducing here. Okay, what happens when I reduce? Still, the drum brake will have a higher brake factor than the disc. But what happens? The change you can see here, right? The delta B brake force drum with respect to this delta u. You see the gap is higher than the disc. See how I can conclude, okay? And I can also tell in that way, say, for the brake fed application where with respect to the reduction in nu and with respect to the increase in the temperature, that is going to be the brake fed phenomena. See now, nu is nothing but the friction sensitivity. It is the indicator of the change in the brake performance with respect to a change in friction nu. Now, how I am going to have? You see here, the disc brake have a lower friction sensitivity, nu sensitivity. Disc brake will have a lower sensitivity. Okay, you see here with respect to the reduction in the friction, what happens? The sensitivity. Okay, the disc brake is it is having a lower friction sensitivity than the drum brake, which means this disc brake is more reliable is for the brake force output. Okay, with respect to the brake force output, the more reliable is disc brake compared to the drum brake. And also this disc brake is also having the better heat dissipation characteristics compared to the drum brake. So these are all the ways that how you can compare the drum brake with respect to the disc brake. One advantage is in the case of drum brake is that the brake factor is going to be higher. When you have the high brake force, what happens is that the net brake force output is going to be higher for the same actuation force. And next thing is that for the even for the smaller actuation force, you can have the required amount of brake force to actuate the drum than that of the disc. On the other hand, the disc brake is much better for the friction application with respect to the friction sensitivity. When you lower the friction, um, you will have a better reliability with respect to the brake force output in the case of disc brake than that of the drum brake, and also this disc brake is having the better heat dissipation characteristics. So let's see. See, in most passenger car, always disc brake is used in the front, and then drum brake is used in the rear, right? And not only passenger car, even for a truck application as well, you normally have the disc brake in the front and then the drum brake in the rear. The reason behind is, typically you need to have why you need to have more disc means why you need to have the disc brake in the front and then drum brake in the rear. So based on this graph, so you need to have typically more normal road is available on the front wheel. Okay, so if you have more normal road, then what happens? You also have more potential braking force from the front. So that's why it's better to go with the disc brake in the front and then drum brake in the rear. And you need to have a reliable brake on the front. So we have also seen the reliability. In order to have that, we need to have a disc brake in the front, and then choosing the disc brake is the best option because of these three reasons. First one is that you need to have the more normal road which is available on the front wheel, and you need to have the more potential braking force from the front, and you need to have a reliable brake on the front, so which is very much important. Hence we are going for a selection in such a way that disc brake is on the front. Next comes the hydraulic brake system. Let's see one with hydraulic, and then we will see air brake system. We will see ABS. We will see in the next class. Okay. See, this hydraulic brake system is the one you see here. This is the complete layout. This is the front wheel having the front disc brake, and rear is a drum brake. Okay, and you have a when the driver applies the pedal. Okay, yeah, this is how the driver pedal is a source of energy or a mechanism of applying the brake. So the driver presses the foot pedal, then you have the vacuum booster, and then you have the master cylinder where the hydraulic fluid goes from the vacuum booster to the master cylinder, and from there it goes to primary circuit and also the secondary circuit. So primary circuit is the one so where the fluid comes here, and then it goes to the left wheel of the front wheel, and then the right wheel of the rear. Okay, you have the combination valve also, which is highlighted in yellow. And then secondary circuit is the one where the fluid goes to the right wheel of the front brake disc to the top of the left wheel of the rear brake drum. Okay, and we here they are going to use an incompressible brake fluid as the energy transmitting medium, and this vacuum booster is the one which augments the driver brake input force. and you have the master cylinder where the mechanical force is converted to the fluid pressure, and you have dual circuit, one is primary circuit, another one is secondary circuit, and you have the diagonally split or you have the split because you have the diagonally primary circuit and secondary circuit. It is kind of X split or it's going to be the diagonal split. Okay. Now let's see once the driver applies the foot pedal, what happens? The fluid goes to the vacuum booster. Here, what happens before brake application and after brake application? So when you apply the brake, which means when the driver pushes the brake pedal, what happens? Uh, you have two region. This is the first region. This is the second region. And the first region is before the diaphragm, and the second region is after the diaphragm. And in the case of vacuum booster, before brake application, you call this P1 minus P2 into the effective area, which is nothing but the net force coming from the vacuum booster. Okay, what happens here is you have the air in between at the partial vacuum when doing the one where before the brake is getting applied in the case of hydraulic brake system. And after brake application, what happens? Same P1 minus P2 into area effective is the one which you are going to get here. But here in this case, after brake application, this P1 and P2 will become equal. Okay, so that after brake application, what happens? The fluid passes from the vacuum booster to that of the master cylinder, and then from the back the flow comes like this, and you have the push rod which pushes the fluid, which pushes the brake fluid, and you have the piston, primary piston and secondary piston, or the primary circuit and then the secondary circuit, and where it goes like in the X split or in the diagonal split side. Say assuming that if you have a leakage in the secondary circuit, if there is any leakage, and what happens? Uh, you have the partial thing which is activated with the above a primary circuit, and it will save for the application of the brake basically. And you have a wheel cylinder is uh, which is shaped like this. You have the cylinder, you have the master cylinder here, and then the function here is that the wheel cylinder converts the fluid pressure into an actuation force on the brake shoe of the brake drum. You also have the combination valves. This is what is it is the combination valve, which what we have told, and this is found in most cars with front disc brakes and then the rear drum brakes. Okay, and you also have the proportionating valve, where it ensures that fluid pressure provided to the front and then the rear brakes are proportionated, and it is been distributed equally and appropriately. And in the case of the proportionating valve, you need to have the more brake force output from the front brake, and this disc brake also requires a more actuation force to generate a desired brake force. You have the pressure differential switch in the case of hydraulic brake, where it is used to alert the driver if there is any loss of pressure in either circuit. And you have the metering valve, where the drum brakes takes slightly longer to be applied than the disc brake. This valve also delays providing the higher brake pressure to that of the front disc brake, where it helps for providing the sufficient time to apply the rear brake drum. And these are the desirable properties of the brake fluids. It's having high boiling point, low compressibility. It should not corrode the metal parts. It should lubricate properly. It should have the low toxicity. And Department of Transportation is called DOT. They have prescribed the common brake fluids that can be used is glycol-based fluids. It's called DOT 3 or DOT 4. It's mostly used in vehicle application having the low compressibility, and it's good for the application where its boiling point reduces if it gets mixed with it. It's called hygroscopy. And even they are also going with dot 5. They are going for silicon based fluids. It's called non-hygroscopic, or it can be a stable boiling point or high compressibility. And even you can use the water pockets that can have the um, even the water pockets can form that lead to the performance degradation. So again, there are different parameters for the brake linings, where it is should be made up of fibers having the proper rigidity and strength. Yeah, the material that is used for the brake lining can be either asbestos or steel wool or aramid fibers. It should have the good heat dissipation. It should be good for fire resistance. It should be inexpensive and also carcinogenic. You need to use the proper fillers, benders, and friction modifiers when you're going for the brake linings. So, for example, the fillers should have the high life. It should fill the space and it should have minimum cost. It can be made up of barytes or clay or calcium carbonate or finely ground metal powders. The binders, okay, basically the phenol formaldehyde binders are being commonly used. It should have the glue holding ability, where the glue should hold the lining material together. And you have the friction modifiers as well in the case of hydraulic brake application, where the elastomers have been used, which will improve the mechanical and wear properties. And also the brass and zinc have been added to control the abrasive properties as well. Next comes the air brake system, where it uses the compressed air as the energy transmitting medium. This air brake are being used in heavy commercial road vehicles. In the case of trucks, buses, trailer application of the brake pedal meters are is basically used mostly for the commercial vehicle. But however, what happens is see, this both hydraulic and then the air brake is a medium, where it either uses compressed air or it uses the hydraulic fluid, incompressible fluid as the source. But what happens? The foundation brake remains same. Okay, what is foundation brake, drum brake, and then disc brake? What we have seen, the disc brake is used in the front, and then the drum brake at the rear. That remains same. That configuration remains same. So this is the layout of the air brake system. Um, where the air is stored, where is sorry, the air from the atmosphere comes and then the compressed air is stored here. Just a second. Okay, so where the compressed air is stored here. Sorry, let's just 2 3 slides. We'll close this. We have only 10 minutes time. Uh, I'll You can ask if you have any queries up to this. Then I will take this break after 2 3 minutes. You can post your questions if in case if you have any queries if you have, and then we will see this break shortly.
No doubt, sir.
Yes. Okay, so we'll see this now. The airbag system. See, what I was telling is we have the dual circuit even here as well, because if in case of one fails, other circuit will help. So here you have primary circuit. Okay, so compressed air is been stored here and it goes to the one to the primary and another to the secondary circuit. So you have front and then the rear. You have the brake chambers, you have the relay valves. Okay. See, you also have a drum brake in the rear and disc brake in the front. So here the drum brake is having the camshaft, the yes cam. This is how it looks. Yes cam, and you also have the slack adjuster in this case. What happens? You also have a brake valve. So here you have the quick release valve. So this is the quick release valve which will enable the quick release exhaust of air from the front brake chambers once the brake has been released. And you also have the relay valve which helps for faster application and then the release of the rear brakes. And you have the slack adjuster here, and the compressed air comes in this way, and it pushes and it comes like this way in the through the brake chamber. So this is the brake chamber, okay. And what we have told is in the rear, what we use is the drum brake. Okay, so that's why it is schematically mentioned as drum brake here. And this compressed air pushes the push rod and then it goes and then it moves the brake screw towards the brake lining and then brake lining moves towards the brake drum and then this hold basically this holds the brake drum such a way the deceleration of the vehicle is going to happen. And again, you have the relay valve which helps for faster application release of the rear brakes. You also have a treadle valve. So this is a treadle valve or brake valve. And in this case, you have primary circuit and secondary circuit, right? What happens? The supply port is nothing but yes, E is nothing but the exhaust port, and P is nothing. D is nothing but the delivery port. And when the brake is not applied, okay, when the brake is not applied, what happens? Uh, when the brake is not applied, what happens from D to E? From delivery port to the exhaust port, the fluid goes. What happens when you apply the brake? When you apply the brake, uh, the air from the reservoir means air enters in this direction and it occupies and then it goes to the secondary and then the primary port. And when it goes to the primary and then the secondary circuit, what happens? It goes in a diagonal way where the primary circuit will be with the front wheel left side and then the rear wheel right side, and also the secondary circuit will be for the front right side and then the front means rear left side. So it goes in a diagonally left cross split so that the brake is applied. And as I told that we also have a relay valve where it controls the port that receives compressed air from the primary circuit to that of the throttle valve. You see here, this is the push rod stroke versus the brake chamber force output. When the push rod stroke is getting increased, what happens is that the brake chamber force output gets reduced. Okay, and then you also have the readjustment limit. And as I was telling, this is the layout how it looks. You have the slack adjuster. Once this push rod pushes, the slack adjuster will move, and it moves the cam is cam, and then cam roller, and then brake lining, and then the brake drum. And this is the layout of different components involved in this airbag system, having the gear, slack adjuster. This is nothing but a slack adjuster. Okay, and then this slack adjuster can be either manual or it can be automatic. And the output force from the brake chamber reduces significantly once the push rod strokes exceeds the readjustment limit. When this push rod stroke is exceeding this readjustment limit, what happens? The output force from the brake chamber reduces significantly, and you also have the feedback which is available to the driver, which will lower in the case if there is any leakage is going to happen. Say for example, if there is any leakage is going to happen here in the rear, then you also have a feedback which is given to the driver that there is a issue in one circuit, so that the driver will take appropriate action and he will stop the vehicle. And the last brake system which we can see in the next class is ABS, which is nothing but anti-lock brake system. This typically we call this as ABS, and this helps to prevent the lockup of wheel during braking. You know, many times the wheel gets locked during the braking. Okay, it can be applied for a front or a rear, and this ABS is the one where the wheel is said to be locked when the vehicle wheel stops rotating, but the vehicle is still in motion. So you see, normally this is also a dangerous condition where when the vehicle is still in motion, but when the wheel stops rotating, what happens? It is again going to be a lock, right? But still, it is not a complete brake had happened. Okay, so the brake complete braking is the one where the complete deceleration should happen. So what is the use if the vehicle is still in motion, even though the wheel gets locked? Okay, so in order to prevent these things, you need to have a system called ABS, anti-lock brake system, which will prevent the lockup of the wheel during braking. Okay, so we'll see this in the next class. So